Good day, everyone. Now, welcome back to our channel. How to let's take up a new topic in Autodesk Inventor, or in new tool for that matter. For those who haven't subscribed, kindly click on the subscribe button as well as like and share. Thank you. Now, last time we created from a problem, we created a spring, right? And we used the coil tool. Now, for today's topic, what we'll be doing is we'll be drawing an external and internal thread using the coil tool also. So for those who haven't have a background on thread, this is how the thread looks like now. We have the pitch here. The pitch is the distance between two crests. This is the thread angle. This is the depth of the thread here from the topmost portion up to this point. This point is what we call the root. And then we have the minor diameter here, that is root to root, the pitch diameter here, and we have the major diameter or the nominal diameter. Okay, so this is how the thread looks like. And today, we'll be drawing a thread with a specification of M12 by 1.75 by 30 slash 5G 6G. Now M stands for a metric thread. 12 stands for the nominal diameter, or the outside diameter for that matter, for external thread. Now 1.75 stands for the pitch, of course, in millimeters. And 30 is the length of the threaded portion. 5G and 6G, here, tolerance position, G, tolerance grade, this number here. So the first number in the first G refers to the tolerance with respect to the pitch diameter. And the second number here, tolerance grade, and this one is the tolerance position, refers to the major diameter, which means 5G and 6G here. 5G indicates the tolerance class for the pitch diameter, and 6G indicates the tolerance class for the major diameter. You may refer to tables on threads if you want to know more in terms of the tolerance grade and then the tolerance position. Let's continue. Now this is how a sharp V thread on ISO metric thread looks like. Now we have two points to consider here. The first one is H, which is the depth of the thread, and it is given by the equation 0.86603 times P. P is the pitch. And the other one is R, which is the radius at the bottom of the thread here, and it is equivalent to H divided by 6. Now, our sample is M12 by 1.75 by 30 slash 5G 6G. So with that, given the pitch here, we can solve for the depth of the thread, H. By substitution, we have around 1.516 mm. That is the depth of the thread. And then we can compute also for the radius at the bottom of the thread, given by H over 6. So we have already a value of H here. We divide this one by 6. And we have 0.253. Okay? So these are the data we need to draw a thread. So to start with, we have Inventor open. And then we start to say, for example, on the XY plane or the front view. Now we draw a circle here. And the circle diameter should be 12. That is the nominal diameter, M12. Click on Finish Sketch. We extrude. Let's say a value of 30. This is our figure. Okay, and then what? We will have a jumper, say for example, a jumper value of 1.5 as an example. We have that value, or let's say 1. So we have that value there. Okay. So this is how our figure looks like. Now I click on Start Sketch. I will find the YZ plane. And then may I slice the graphics here. Okay. Now I will draw now the profile of the thread. Okay. So the profile of the thread looks like this. Okay. Let's extend, remove that pointer. Okay. And then we draw a line here. And this line be perpendicular to this edge. Like that. And then let's have a dimension here. What is this value? This value is 1.75, the pitch of the thread. Okay, this is the pitch of the thread. Why? Because this is one crest, this is another crest, and the distance between two crests is the pitch, which is 1.75. And then we can dimension also this here. Now the angle is 60 degrees. Okay. Now the question is everything okay? We'll check. We'll dimension this. It's not. This is 1.78, so it should be 1.75 also. Like that. How about this one? So it's now 1.75. You will see now an error, so we'll not accept. So we have this figure here, and let's have, let's make this one a construction line. Okay, there we go. Now, the radius here is 0.253. So I click on Fillet, type radius 0.253 there. I select this and this. Okay. And then let's draw a line connecting this end point here to that point. Now let's make this line a construction line. Now we apply a vertical constraint so that it is now vertically constrained with that part of the solid. So one dimension is needed. Now we can dimension from that to that portion there. Let's say we make this one a 3 mm distance. So we have that. So it's now fully constrained. I click on Finish Sketch. I have that one. Disable dimension visibility. So I have that. I click on the coil tool. Automatically, the profile is selected. I click on the axis. I select the Z-axis here. Now it's opposite in direction, so I click here. So the rotation is clockwise, so it's correct. Now on the coil size, I will select pitch and height. So the pitch there, M12 by 1.75, it's 1.75, the pitch. And the height is 30 mm, but we have here an offset of around 4. So let's make this one 40. And it should be a cut option. I click on OK. So what you see now is I have drawn a thread. This is how it looks like. That is now a thread. Hello? Now, let's start a sketch on this face. And then let's draw a circle here. Let's say 11.5. 0.5 mm smaller than the nominal diameter. I click on Finish Sketch. I extrude the tonic value of 1.5 mm. That is what I have. I start to this sketch again on this face. And let me draw a polygon somewhere here. Okay. And let's have a vertical constraint on this edge. So here we have one dimension needed. I dimension this distance. Let's say I make this one 16. So fully constrained. Click on Finish Sketch. This is what we have now. Click on Extrude. Type an angle of 10. Extrusion height is 10 mm. Click on OK. So far I have this. I click on this face again. I will draw a circle here. Okay. And the circle should be tangent to this edge. Okay. So fully constrained now. I click on Finish Sketch. Now use the Extrude tool. Opposite direction. Select all. But in this case, you select intersect. And here you click more taper angle, define 45 degrees. This is usually what you see on a bolt. I click on OK. This is not the result. I change it to my material, which is so this is how it looks like. Very fast, very simple. So what I have is an external thread. The specification is M12 by 1.75 by 30. If you want, we can click here and then find the YZ plane. And then I slice the graphics so that you can see. This is how it looks like. If I rotate that, this is what you will see. There you go. Okay? Okay. So, that is an external thread. Now next, we'll create an internal thread. Now the specification is the same, M12 by 1.75. So I click on Start to the sketch. I select the XY plane. Now in this case, I will draw a polygon. Okay. And then I have a vertical constraint to this edge. One dimension is needed. I dimension this edge and this edge and have the value of 16 mm. Click on Finish Sketch. Now I extrude. Let's say I extrude the value of 10 mm. I click on OK. So this is what I have. Okay. And then I use the Fillet tool. Radius is 2. I select the loop mode. I hover my mouse there and then click on OK. Apply. Okay. So here I have that at the back. Next, I start my drawing on this face. I'll be drawing a circle here. But the question, what is the diameter of the circle? The diameter of the circle is the top drill size. What is the top drill size? That is the size of the drill to use in creating the hole. And the top drill size is given by the outside diameter or the nominal diameter minus pitch. Now, on our example, the nominal diameter is 12 mm and the pitch is 1.75. So 12 minus 1.75, I have 10.25. The diameter of this one is 10.25 mm. This is the top drill size. I click on Finish Sketch. Extrude. I select a cut option. I go All. I click on OK. And then I create a jumper here. The shear jumper of 1.5. Then I click on OK. This is what I have. I click on Start to this sketch. I click on XY plane. I slice my graphics. That's what I have there. Now, I will draw, excuse me, I will draw a line here, something like that. Another triangle, and then I draw a line here. So this line here should be perpendicular to this line. I will dimension this line, and this line is equivalent to my pitch, 1.75. There you go. I change this line to a construction line. Okay. Now this line should be also 1.75. How about this one? The same, 1.75. Okay, there you go. And then what? We have a 0.253 fillet radius at the bottom. So I click on fillet. I type 0.253 here. I select this. Undo. How come? I need to dimension let's accept, and then I click on fillet. Okay. So I have now that fillet. Okay. Now let's move. Let's move all of this to the drawing from that point there to probably somewhere here. There you go. And then let's do a line connecting that point and that point there. Now we change it into a construction line and have here the vertical constraint. So what we have is that. So one dimension is needed. I can dimension from that point to this point, let's say 3 mm. So I have now a fully constrained the drawing. I click on Finish Sketch. This is what I have. Now I will hide the dimension visibility. Now let me click on the COIL tool. I click on the axis. I select the Z axis, opposite. COIL size, pitch, and height. Type 1.75. Now the height should be, let's say, around 18 mm. With a cut option, of course. I click on OK. So what I have is this one. Okay. If you want to see, I will change the material to chrome blue, and then I click on start to the sketch on the YZ plane, and then I slice my graphics. Now this is what you will see inside. Try to take a look. This is the inside of the inside of the internal thread. Okay, so creating a thread is not that difficult. No, it's very easy. Whether it's an external thread or internal thread, it doesn't matter. So the example is an ISO metric thread, 60 degrees. Okay, so my discussion on this topic ends at this point. Kindly like, share, and click on the subscribe button below. Thank you very much.